Good afternoon to our Italian and European followers, and good morning to the Americans and the rest of the world. Unfortunately, we are a little bit late due to meteorological reasons. This is the second day of Inn4mech, and I am Filippo Astone, Managing Director of Industria Italiana news magazine, with the pleasant duty of answering this day of discussions. But before introducing the two plenary guests to a day that will be dedicated to circular economy, I hand over to Michele Tosi of Trentino Sviluppo, who will recap the day of yesterday and tell you something about today's contents and the reasons of Trentino Sviluppo.
Thank you, Filippo. Let me say first that I'm very glad to have reached over 150 attendees yesterday and today, and it is a very big number for a conference, a symposium like that, which is very technical and very focused on a very specific sector. Also, the quality of the speakers and the quality of the presentation was very, very, very high yesterday, and I think this is thanks to the technical committee that chose the speaker, chose the papers, and decided to invite some special guests. I would like to thank them all because this is the real core of this event. Luca Capra from Trentino Sviluppo, Paolo Bosetti from the University of Trento, Gaetan Buzard of Siemens, Stefano Fiorati of CNH, Andrea Lucchi from Dana, Alfredo Maglione of Optoi, Angelica Pier from the University of Trento, Enrico Sedone of CNH, and Lorenzo Serrao of Dana. So thanks to them because they really did a great job. To the people that are watching us at the moment, I will also remind them that the recording of yesterday's presentation is available already on the platform, and obviously tomorrow you can see the recording of today and so on and so on. Another thing that I'm really happy to say as well is that you can book your appointment with other speakers, with other guests, and obviously it's not going to be the same as being in person because we would have liked to have a live event, but obviously we cannot. But it's all about contamination. These events is all about trying to understand from other people, from other environments, you can get innovation in a very complex environment like us, the off-highway environment. Another thing I would like to remind is that on Thursday morning Italian time, so probably at night in the US, there is a brokerage event organized by EAN, the European network that we are part of. Is all about, again, knowing more people and trying to meet and get contaminated in the same kind of sector. We organize that. It's a kind of parallel event, but it's connected to Inn4mech because we try to attract people from different environments and for the same reason I'm trying to say today. And obviously, last but not least, today we're going to have the same structure as we had yesterday and tomorrow as well. So two keynote speakers, and then a round table managed by Filippo Astone, and after that, a workshop with a lot of questions, a lot of presentation that will be moderated by Paolo Bosetti from the University of Trento. Now I'm trying to answer your question, Filippo, about why we decided to dedicate an entire day on circular economy, because probably it's not easy to understand in a sector like the off-highway. I would like to answer, as I did yesterday, with a few words. And the few words today are best practices, because everybody's talking about circular economy at the moment. But I personally believe that a lot of companies, a lot of entities are calling circular what circular is not. The public administration is somehow trying to push citizens to become more circular, but I think the citizens are struggling sometimes to understand what circularity is. And the European Union is allocating over 5 billion euro for circular economy project, but this money is still mostly unused. Because the question is, do we really know deeply what circular economy is and how this concept can be applied in different sectors? Especially, and most importantly, how can it be applied to a complex sector such as the mechanics sector? I think there is a lot of confusion between circular economy and reuse of waste. Probably circular economy is much more than that, much more than reuse of waste. Circular economy is not starting from the end of the circle, it's starting from the beginning. The real circular economy is when you design your product and service in a circular way, in a circular kind of model. But the process of changing the way we produce in the product and designing the product and services is very complex, is very complicated. So we need really best practices. We need something more operational to understand better how to manage this kind of big, massive change. Given our role of trying to push innovation into the territory, Trentino Sviluppo a couple of years ago decided to create this circular economy academy called Circular Rethinking. And the idea is to try to train the circular economy professional of the future, try to help the companies to get some practical tools to manage the idea, to manage the process of changing the process from linear to circular. And in line with this strategy, of the Circular Economy Academy, we are glad to focus an entire day of Inn4mech on circular economy, to try to answer a few simple questions. How circularity is applicable to the mechanics and mechatronics world? Can we have some examples of circular economy off-highway machines and tools? Because it's probably easy, you probably agree with me, that it's easy to apply and imagine circularity in some sectors such as retail, building, water management, and production of materials. But imagining circularity into the mechanics, mechatronics, and even better in the off-highway world is probably very difficult, it's not straightforward, and let me say that is a big challenge. But I'm sure with the level of the speaker today, we're going to have a lot of answer to our questions. So, Filippo, back to you to introduce these fantastic speakers.
The title of the speech is the Efflics project for the increasing use of eco-friendly fluids in volumetric machines. The stage is yours.
Thank you very much. Good afternoon, everybody. So I'm going to present our project. And first of all, I would like to introduce the framework in which this project is inserted. In fact, this project is a financed project, funded project within the smart specialization strategy of the Emilia-Romagna region, which found some some project in order to develop some technologies, new technologies, in particular to be that should face some territorial, I would say, opportunities. So, in particular, this project is called Eco-Friendly Fluidics for Fluid Power, and is aimed at the development of analysis and design methodologies in order to introduce eco-friendly fluids in the hydraulic machine sector. And this wants to reduce and in perspective eliminate the use of mineral oils and synthetic fluids. And to do this, we have chosen, we have tried, we have tested a number of fluids in different, with different technologies. And so the aim, as you can see, is that we would like to tackle the entire production chain in which the hydraulic volumetric machinery is inserted. And in particular, within the Emilia-Romagna area, where a high number of companies connected with fluid power transmission sector and with sector in which components of hydraulic or aerodynamic system are used, such as automotive, agricultural, and construction. In particular, as you know, the automotive sector is at a very high level in Emilia-Romagna. One of the most, I would say, difficult things to handle with this project is that it is carried out by 4 different entities, which are 4 technological transfer centers. In particular, the University of Ferrara, University of Modena Reggio, the CNR STEMS, the National Research Council, and the National Research Council ISTEC. And these are 4 technology transfer centers within the entities. And we have got 3 supporting companies, which are OilSafe, Dana, and ZF Automotive Italy, which are supporting this project and which are giving us, I would say, the reality check of what we are doing. And they are providing real components for testing our technology. So the project is divided in 4 different tasks. The first task is a phase 1, called phase 1, is the computer-aided engineering design of volumetric machine with eco-friendly fluids. And so, first of all, we have set up a database with oils suitable to be considered for eco-friendly applications. So we have we have considered a number of oils, made a database with all the characteristics, and then we choose 3 commercial eco-friendly oil, which are the biohydrant TMP46, biohydrant SC46, and the HLP synth A46. And then we have chosen one additional oil, which is, I would say, the most eco-friendly oil that can be imagined. That is the rapeseed oil. We have found in these 3 commercial eco-friendly oils. We have provided to all the partners these three oils, and then also the rapeseed oil. The second part of the phase 1 was the development of methodology in order to design a volumetric machine with the most, I would say, innovative tools that can be used for the development, for the design of volumetric machine, which are both lumped parameters models and CFD models. Unluckily, I had a a motion here with the CFD, but the slides didn't allow me to show you the video. However, you can see that we reached a very high level of confidence, of fidelity of our models. And the aim is to develop these methodologies with respect to the use of eco-friendly fluids, which have different properties and different behavior with respect to traditional oils. And these are other images which in which we can see that we have tested the oil with respect to classical synthetic oil, and we found some improvement in volumetric efficiency. And also, if you can see the pressure signature, the pressure ripple of the external gear pump that we have used, coming from ZF, a real geometry, and we can compare the different behavior of the four oils. Then we have developed a methodology for simulating with CFD the oleophobic behavior. Why we have developed a methodology to deal with a oleophobic surface with simulation? Because the second phase is the use of oleophilic coatings to be used within the volumetric machine in order to enhance the performance of the machines when used with eco-friendly oils. And here you can see that several coatings have been investigated, and at the end the choice was addressed to the silicon oxide nanoparticle coatings because it showed a very high oleophilicity towards several lubricants, and it has a low cost compared to other oxides, and there is a wide availability of the commercial product. So you can see here how the contact angle on the surface change with the coating and uncoated, with the surfaces uncoated or coated. And you can see that the contact angle decrease in a quite sensible way. And this is the images of the coatings that the Research National Council, Inn4mech, have coated on the stainless steel of some specimen in this case. And you can see on the right, you can see that there are the images of the droplets uncoated with a contact angle of 33 degrees. And in the second picture, you can see the coated contact angle with only 8 degrees. So a very high, very good oleophilicity. And this is made with the rapeseed oil. So the aim is at the end to coat some real, as we would like, we are coating wash plate, the slipper, the bushing, and so we will then reassemble the that I will show in the first phase in order to see the effect of coating. Again, the third phase is the development of a sensor for aging assessment of eco-friendly fluids. So one of the main problems that could happen to eco-friendly fluids, in particular to rapeseed oil or something, or oil similar to rapeseed, is the aging of the oil. And so the CNA, the Research National Council STEMS, have developed this kind of electronic nose, which is able to sense the aging of the oil itself. The methodology is based on a test bench and on aged, I would say, aging procedure, which has been supported by OilSafe, by the industrial partner OilSafe. And so by developing, as you can see, a MOX gas sensor, it is possible to sense the odor of the oil, which is, since it is changing with the aging, we are able to monitor this the aging, and so to have information on the health state of the oil. You can see in these slides the response of 3 different MOX gas sensors, and you can see that we have validated the method, and we are currently developing and optimizing the sensor. The first phase, the fourth phase, and the last phase is the experimental testing. So we have developed a test rig, which is installed at the University of Reggio Emilia, and we want to make an experimental qualification and monitoring of the influence of the work cycle on the useful life of the environmentally eco-friendly fluids involved. Then the assessment of any loss of performance of the volumetric machine associated with it, and to address and to test the application of the coatings, and if there are advantages in applying these coatings. And then we want to evaluate the efficiency and the effectiveness of the electronic noise. So this is the test rig that has been developed, and this is the last phase that will be performed in the next month until the end of the year. So this is end my presentation. I'm Michele Pinelli. I'm the scientific referent of this project. I would like to say that if you have got questions or curiosity on this project, there are a number of questions that I can reply directly, but other questions may be related to phases that in which I'm not directly involved. Maybe I can forward to the other researcher involved in the project in order to reply to your curiosities. So thank you very much.
Thank you, Michele, for your interesting presentation. I'm starting the Q&A with a question. You presented the coating of the mechanical components with silicon oxide particles, nanoparticles, for improving the wettability of the surfaces with oil. My question is, since we are talking about surfaces that are typically exposed to wear, to friction wear, how do those nanoparticles affect the mechanical wear of the same component, and how they are affected by friction, for example? So if this type of coating degrades with time, and how much, how long it resists, and so on.
So thank you very much. Yes, this is a good question, because this is one of the main issues that the researchers from the laboratory have faced during the development of these nanocoatings. They have maybe more than 20 years experience on these coatings, and during the years they have enhanced the capability of these coatings to resist to wear. So from regarding the wear characteristic, they do not have a particular influence, but they tend, of course, to be removed by wear. But this kind, in particular, this kind of coating with the solid oxide nanoparticle have demonstrated to be to have a good life, a good endurance. I would say that I'm not the researcher that deal with this kind of research, so I can forward this question to the researcher that deal with this part. However, what I can say is that this is an issue that is always one of the part of the development of the coatings that is taken into account.
Any question from the people in room or from home? It seems that we have no other questions. So
okay.
Thank you again for your presentation. We can move.